Hey guys, I wanted to go through a couple of the dividing radicals setup, or essentially rationalizing the denominator with radicals. So here I have one example of a monomial, and then we'll have an example of a binomial in the denominator after this. Okay. The whole goal here is to get rid of a radical in the denominator, which is our rationalizing the denominator setup. Okay. We're going to do this by multiplying. If it's a monomial, we multiply just by whatever the radical is. Okay, so although this says 4 square root of 7, I'm only going to multiply the denominator by square root of 7 to get rid of this radical. And the reason why that works, if I do the square root of 7 times the square root of 7, it gets you the square root of 49, which the square root of 49 is 7. And that'll work for any of our numbers when you multiply times the same number in that radical. Okay, so when I do this, again, I multiply by that radical in the denominator. From here, then, I would get on the denominator 4 times 7. Again, 7 times 7 gives me 49. Square root of 49 is 7. In the numerator, I would have 3 and then square root of 84. Or 7 times 12. Again, when we multiply with our radicals, we can multiply radicals times radicals and whole numbers times whole numbers. For this, we would just have the radicals being multiplied together. Then I would do my simplifying. So if you can simplify, go for it. So here I have 84, and I'll just kind of write this off to the side. I'm going to do my 84 and do my factor tree. So I can go with 4 and 21, 2 and 2, 3 and 7. Because it's a square root, our index is 2, so that tells me I need a pair of 2 to come out. So for this one, my pair is just a pair of 2's. So that brings out a whole number 2. My leftovers are the 3 and the 7, so if I multiply 3 times 7, it gets me 21. So up above, I have square root of 84 and the 3 times that. So I would have to then do 3 times the 2, because again I have that 3 in front of the 84. So 3 times 2 gives me 6. So my numerator would become 6 square root of 21. Okay. In our denominator, I have 4 times 7, which is 28. This is good. Awesome if we get here. We have to remember at the very end, everything needs to be simplified as far as possible. So here I do have 2 whole numbers. The radical, again, is not going to be something I can simplify at this point because it's just that 3 and the 7, and I can't simplify a radical with something that is not a radical. So here it would just be 6 and 28. I can divide both of those by 2, so that would be my simplifying the fraction. So I would end up with 3 square root of 21 over, divide this by 2, would get me 14. So I would have 3 square root of 21 all over 14. Okay? So this would be our step. Again, if it's a monomial, you're only multiplying times the radical in the denominator. Not any other number, just the radical in the denominator. Okay? Our second problem that has a binomial in the denominator will be a little different. You are going to, instead of multiplying just by the radical, you are going to multiply by what's called the conjugate. Okay? So if I have a problem that looks like this, it'd be like 3 plus square root of 7 all over 2 plus 2 square root of 7. Okay? Occasionally or sometimes you'll just have a single number on top. You'll just distribute that number times what we're multiplying over here on the right side, but I wanted to give you one that has binomials on top and bottom. Okay? So for this problem, or any problem that we have a binomial, 2 terms, again, you can tell when you're going to use this method when you have a plus or a minus in the denominator. Since there's a plus here, the conjugate would be the exact same numbers, but just flipping that middle sign. So right now we have 2 plus 2 square root of 7. So I'm going to multiply times the conjugate, which would be 2 minus 2 square root of 7, on the top and bottom. Again, the reason why I'm able to multiply it times top and bottom, it doesn't change the value of the problem, because if I divided this, 2 minus 2 square root of 7 divided by 2 minus 2 square root of 7, it would get me a whole number 1. And if I multiply a problem times 1, it doesn't change its value. Okay? So here, when I multiply this out, the biggest thing is to remember you are distributing. Okay? So we're going to distribute each piece into my other parentheses. So for the denominator, I would have 2 times 2, which would get me 4. 2 times negative 2 square root of 7, so 2 times the negative 2 would get me negative 4 square root of 7. Again, when you're multiplying, you can only multiply whole numbers times whole numbers, radicals times radicals. So the 2 would only go times the 2 on the outside. Our second term here has to be distributed in as well. So 2 times 2 gives me positive 4 square root of 7. Second one will be 2 times 2, which is negative 4, negative 2, so it would be negative 4. Square root of 7 times square root of 7 gets me 7. Okay, again, that's that rule. Square root of 7 times square root of 7 gives me square root of 49. Square root of 49 is 7, so we have that 7 here. Okay. You can write this out as 4 times 7. A lot of times I just say, well, it's 4 times 7, so I'm going to put 28. So we can put the 28 there to hold that spot. Okay, so that's my denominator. When I look at the denominator, we combine like terms if we can. The nice part, or the reason why we're doing this, is to get rid of the radical. That's the end goal of all these problems in the denominator. So, in this step, when I multiply by the conjugate, my middle terms, or where the square roots are, should cancel out. If they don't, something went wrong. Okay, you may have multiplied by the wrong value there. But here I have negative 4 square root of 7 plus 4 square root of 7. So these would just cancel out. So my problem would be 4 minus 28, which 4 minus 28 for this problem would give me negative 24 in the denominator. Okay, so the denominator is fully taken care of. We multiply times the conjugate. We got rid of our radicals. I have a whole number. That is what we're looking for. That's what we should be getting. Okay. On the top, we're doing the exact same idea. We are distributing everything through. So here, if I distribute 3 times 2, I'm going to write this kind of up above. I think you can see that. So I'll have 6. 3 times the negative 2 square root of 7 will get me negative 6 square root of 7. Here I distribute square root of 7 times 2 gets me 2 square root of 7. Square root of 7 times negative 2 square root of 7. Again, I got square root of 7 times square root of 7, so that gets me a whole number 7. I have a negative 2 in front of it, so negative 2 times 7 will get me negative 14. So when I look at this problem, I still have my radicals in the middle that I need to get together. They don't cancel out here. Again, the whole purpose is to get rid of the denominator get rid of the radical in the denominator, which we did down here. The numerator is not the case, so you still will probably have a radical in the numerator at the end of the problem. Okay, so up here I can get these two together. Negative 6 plus 2 gets me negative 4, so I have negative 4 square root of 7. As far as my whole numbers, I have a 6 and I have a minus 14, so 6 minus 14 would get me negative 8. When I look at my problem at the end, I should look at something that is fully simplified and no radicals in the denominator. For this problem, there's no radicals in the denominator, but it is not yet fully simplified. Okay, if I look at all of my whole numbers here, my negative 8, my negative 4, my 24, I can divide all of them by 4, or even if I really wanted to, I can divide all of them by negative 4. Okay, because I like getting positive, so I'm going to divide everything by that negative 4. So if I divide, and again, you can only do this if it divides by every single one of these. Okay, if it could only divide by maybe like the 4 and the 24, and this is like a 7, you wouldn't be able to do this. You would be done at that point. But because I can divide everything by a negative 4, I'm going to go through and divide all pieces by negative 4. Again, the radical has nothing to do with this because it is a radical, and radicals don't combine with our whole numbers here. So if I divide by negative 4, I would get a 2 plus 1 square root of 7, so I'm just going to put square root of 7, and this will get me a positive 6. Okay. Again, some of you might be like, Mr. Schultz, you got a 2 and a 6, so you could simplify that. Again, yes, I could if there was a number here in front of this that also would be divided by that 2 and 6, or be divided by 2, but there's not, so this would be my final answer. Again, you're checking, is there any radicals in the denominator? Nope. Can I simplify it any further? No. Those are the 2 questions when you're done to try to tell if you're actually done or not. Okay. Again, this is called rationalizing the denominator. If you've got any questions, let me know. Otherwise, shoot me an email if you do, or talk to me in class otherwise. I'll see you guys soon. See you later.